Let's talk about last time's homework.
We go with 33.
Yes. Let's see. That was L, right?
Yeah.
You're on L. 33 on L. Hope you all are having a nice day. Sunshine is out. Those of you who were afraid of snow yesterday, snow on the ground, so I'm happy to get back. Is this
Thank God.
No.
I knew we did evens.
33 was the question. Yes, we had to do evens, but
We did. I was gone. I was just assuming you're doing odd.
here's an odd, so let's not worry about it.
I was gone.
We're okay. We'll do it.
Yes, Joe, man, I'm supposed to be even.
Yeah, but we can do an odd. It won't hurt us.
Yeah, we gotta have an even playing field.
So, being there was complaints about having a quiz on Thursday, we'll go ahead and move it just to tomorrow then.
Oh, you funny guy.
Fun guy. Okay. Where do you think we should even approach this problem?
That's why I asked you.
How do I?
Multiply by 7.
Yeah, combination. 7 over 2, 7 over 2 to both sides. Is that okay so far? So both of the exponents become 1 and 1, right? And that gives me 3.5x plus 1 and 6.4x plus 0.7. Not a big fan of decimals, so let's clear all the decimals. Let's see who paid attention in Algebra 1. What did I just do?
Multiply by 10.
Yeah, multiply everything by 10. Do you have to do it this way? No. But we don't have to deal with a fraction then. Okay, subtract 35 from 64, so we're going to get, is that 29? No? Yes? Is that right?
Yeah.
And then subtract 7 to get 3. Is that okay? So it looks like x is equal to 3 over 29, which won't reduce. So here's the little trick on this. When you get a fraction that is usually that nasty, especially about this level of math, if you get something like that, you're pretty much locked in to know that that's the solution. Okay? Yes, you could go and try and plug it in. So you're going to get 105 over 29 plus 10. Is that the same thing as 192 over 29 plus 7? I don't know. I'm sure it is. I don't think it's going to fall out, so I'm pretty sure that would be the answer. Okay. Can you make it a decimal answer? Sure. Go 3 divided by 29. Take it out like 2 decimals. Should be good. What else? Yes,
You did 26.
2/6. And today's just kind of a review day, so
Heck yeah.
we'll look at the review problems as well. 8 equals 2. Okay. So here's the little hint on this one. If I move that 8 over, do I get a negative on the other side?
Yep.
Yeah.
Is everybody okay with that? So let's just use a little logic right now. Can I take the square root of a number? And square root's the key. I take the square root of a number and plug it in. Or can I plug any number in, take the square root of it, and get negative out?
No.
No. So without going any further on this problem, what do you think the answer has to be then?
No solution.
No solution. So there's no solution to this because there's nothing I can plug in for x that I take the square root of that I get a negative answer out. Now, for those of you who are like, well, what if I did it the whole long way? Sure, go for it the long way, which is fine. Was that 37? X equals 37 over 5. So that's kind of a nasty answer, and that kind of contradicts what I had said about the original, but If I plug 37 over 5 in for x, I get 5 times 37 over 5, which becomes 37. 37 minus 1 is 36. Square root of 36 is 6. 6 is not equal to negative 6, so that's why the no solution sticks out. Good? Yeah. 30. All right, number 30. X plus 21. Then I get x plus 3. So we're going to have to square both sides in order to get rid of the radicals. So I'm going to put this in brackets. I'm going to put this in brackets or parentheses. Square, square. So I get x plus 21 over here. And then this side, showing you the math, this means I have this. Do you agree with that? You agree so far? FOIL out the right side. So what's root x times root x? Is x plus, and then I get 6 root x plus 9. Is that okay? Everyone okay on my foiling? Now if I just subtract x from both sides, yes, I do have a 6 root x, but if I just subtract x from both sides right now, this and this are going to cancel each other out. If I bring that 9 over by subtracting it, this is going to become a 12 on this side, and I get this. Do you agree with that? Divide each side by 6. Square both sides, so I find that x equals 4. That's a pretty happy answer. If I plug 4 back in, does it equal on each side? Well, if I plug 4 into the left side, I get 4 plus 21, which is 25. Square root of 25 is 5. And then if I plug 4 into the right side, I get square root of 4, which is 2. 2 plus 3 is 5. So it checks. There's my answer. Cool. Yes,
32.
32. X plus 19. That's raised to 2/5 power. Or minus 1. Minus 1 equals 7. Okay. So
Wait, so do we not need to do it on the calculator like it says?
we can, and on the test, regardless why don't I do it the long way first,
Okay.
and then I'll show it on the calculator as well, show you both ways, and
Okay.
should,
I understand.
So we can have a
you understand the long way? Does anyone want to see this done the long way? Or you just want to see the calculator?
let's do the longer one.
Well, add 1, you get 18, divide by 2. So this is going to come out with 2 answers. And the reason it's going to come out with 2 answers is this is going to, you'd have 17 up here. And then, I don't know, you might get something kind of like this. I don't know. It's going to cross it twice. It's not going to cross it 3 times. So let's plug this into the calculator. Is it okay if I use Desmo? Or do you want me to use graphing calculator? Either one. I'll use graphing calculator.
Wait, on a test on Thursday, are we gonna be able to use graphing calculator?
Yes, there's one part that you can't. Yeah, the non-calculator part is, I mean, it's 4 questions on the site. I mean, honest, like, it's gonna be like last time. I'm gonna hand out the one version, and all of a sudden it's like, I got done handing it out, and then this side's already handed it in. That's how fast it is. All right, so we're doing 32. Is that what we're doing?
Mm-hmm.
So I'm going to have left side is y1. Okay, does that look good? Good. And then the right side I'm going to have is 17. Okay. The only thing I would suggest doing on this one if you go zoom standard, zoom 6, you're not going to see the other one because this is -10 to +10. And if I have y equals 17, that's a horizontal line going through 17. So I would increase my window. I would go to my y maximum. I don't know, take it like to 20. If I graph that, it's not going to help me. Looks like it's coming up. Zoom out. And now it looks like it's going to cross it twice. Do that. And then actually readjust my window.
How are you doing zoom out? Okay, what?
I hit zoom and then out.
Zoom out. It's not hard.
I go zoom number 3 and enter.
Got it.
Alright, so I'm going to change my window. That window's fine. Maybe change this to -20 and +20. This should show.
Ooh.
Very nice. So I want to find this intersection, this intersection. So where's the intersection command? Second, trace. I want to find an intersection. Now before you find an intersection, move your cursor closer to where you want to find it. So we're nice and close right there. Hit enter, enter, and enter one more time. So it looks like -262 is one of our answers or one of our solutions. And then, so -262, and then second calculate and find the other intersection. Before I hit enter, I'm going to move this over so it finds the other intersection. So what the calculator does is looks for the closer of the two intersections that you're at. So move it close to it, hit enter, 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 showing that, and 224 is my other intersection. And I would get that answer if I worked it out long way as well. So which way do I prefer? Honestly, I'm probably okay with both. Okay. Problem is if you just show on the calculator and you get the two answers wrong, and there's no other work other than the answers you got, you're probably missing all of the points for the problem. If you did work it out by hand, you could get some sympathy points, so it's up to you how you want to go through that. Okay? Are we good?
Yeah.
Any others that you'd like to take a look at? 20? Number 20, we're going to get 2x plus 10 minus 2 root x. That's equal to 0. So on this one, I'm going to move the minus 2x minus 2 root x over. Is that all right so far? Square both sides to get rid of the radicals. The biggest error made on this one is you have to realize that's 4x. So on this side it's going to be 2x plus 10. On this side it's going to be 4x. A lot of people might just keep it as 2x, but you're squaring the entire side, so you have to square the outside and the inside. Let's move this 2x over. Divide by 2, so x equals 5. Let's just verify that works. If I plug 5 in, I get 2 times 5, that's 10. 10 plus 10 is 20. So root 20 is the same thing as 4 times 5, which is 2 root 5. Okay? And then if I go plug 5 in, I get minus 2 root 5. So 2 root 5 minus 2 root 5 is 0. Answer works. Anything else you would like to take a look at? Yeah?
So I did that a little differently. I did 2x plus 10. So I did like what you did the first part and just square rooted them out of there, but I didn't subtract or add 2 root x over yet.
Oh, so you like put the whole thing in parentheses and FOILed it out?
Yeah.
That'll get you to the same place with a little bit more work, but should get you to the same place.
Sweet.
Cool.
Yep.
The ideal thing in these is if you have two radicals given and they're on the same side, try and move one of the radicals over and it'll be a little bit easier for you. Okay? Are there any other questions from letter M? I'm sorry?
Yeah, because it's L.
Oh, We're on L? Yes, L, I mean, thank you. We're good? Okay, make sure your name is on that, and any other things you might be turning in, pass them on forward, please. And then also, will you get out worksheet M? Just have worksheet M out on your desk.
Probably a review.
Yeah, worksheet M is a review. If you don't have it, take your phone, take a picture of your neighbors so you can just look at it as we go through it, and there's a front and back to it.
No, we just went through a review problem. Do you have it?
Oh yeah, no.
Hey, I got you.
Yeah, watch your language when you're talking to people.
Hey man, this is a gate.
Christian. This is not a Minecraft server. I'm joking. Yeah, you can talk to me now. I'm just tired of being bullied.
These them?
This kid in front of me is bullying me.
Yeah.
Punch him in the face.
Yeah.
Wait, like, will you send me to the office?
Oh, probably, but
It's worth it, right? Break someone's nose. I mean,
I've had one person whoop on another during class one time. There was a girl whooping on a boy, so
That's fucking awesome.
she took him down pretty good. It was awesome.
he
I
probably
mean, well, you
deserved
can't
it.
really hit her back, or society will be like,
Yeah, I understand.
I mean, she might have just knocked him out. You never know.
Nah, but while I got in between them, she laid one on me. She had a pretty good punch, but she was a big Samoan girl who was easily 300 pounds and about 6'5".
why don't you just like put her in a chokehold and knock her to the ground like some ninja?
Usually 300 pounds.
Yeah. Here's the funny. Her name is Sifa Moli. I have no idea what she's doing these days. So she beat up John Bradford in my class, and then thumped one on me, and so she had to go see Coach Sellers, who was our dean. He was the winningest football coach in the state of Nevada. And I'm in the office. I'm in the office at the same time she came in, and he was just, Joe Sellers was just in total old school, just a hoot. And he's just looking at her, and he's like, "My God, you're big." What? Oh, you beat up John Bradford, huh? And that's how he talked. And she's like, "Yeah, I'm sorry." She goes, "Well, he probably deserved it." I'm just sitting there going, "Oh my gosh." And he says, "Well, I can give you one of two options. I can suspend you for beating up a kid in class, or you play football?" She became one of our defensive tackles. She was mean. She was real mean. Hey, she would be out there. She was the same size and strength as most of the other guys on D&O on the line. And my gosh, she'd be sitting there screaming at the quarterback, "I'm coming for you!" And you'd watch the quarterback go from snapping from behind to go to a shotgun, like panicking because she'd be growling out there. Oh, it was funny. She was good.
Girl power.
So
In the NFL.
not now. Thanks, man. She was.
She must have played for the Patriots.
Nah, she didn't cheat. Ooh, wait.
You're just mad because they're the goats.
Nah, I saw Tom Brady so many years ago play when he was at Michigan. I was at the Big House and he was playing against Penn State.
Yeah.
And so I was
Wait,
watching.
you saw him play in college?
Yeah.
Was he as good?
Oh, he was amazing. That's probably the last time Michigan was able to beat Ohio State that year. I think it was.
You are so lucky.
My wife went to graduate school at Michigan, and so first couple years we were married, we would go back to Michigan and see a game at the Big House,
That's cool.
and that was fun. If you haven't been to Michigan to see a game, I recommend it because there's something about having about 115,000 people in the stands, and it's, you know, you've all seen it on TV. It's when I went, it was just the bowl. It didn't have the sky seats. But man, it was an amazing stadium. You don't even have to like Michigan to appreciate just that many people just out of one game. That's amazing.
Nice.
So
Can I take a picture
my
of your-
wife and I are our first year of retirement. We'll have us traveling to major colleges across the United States and seeing home football games at major colleges.
Nice.
So I thought that sounds like a pretty good first 5 months of retirement.
Go to Nebraska. They've sold
Yeah,
out
the
like
corn
60
huskers
years
are-
Oh yeah. My daughter is looking at going to Nebraska. That's her number one.
Nebraska sucks.
Want to know what the N stands for on the helmet?
Nothing.
Knowledge.
Knowledge.
Oh.
Knowledge. Nothing.
Wait.
It's the
I
joke.
just, yeah.
So, yeah, who knows? You know, old Scott Frost. Hopefully, we'll be turning those guys around a little bit. Never know. Of course, with my brother from another mother, his name's Justin. He's an Ohio State fan. I was telling him, I said, yeah, you know, I saw that McCaffrey in Michigan play, and I said, you know, the other McCaffrey's committed to Nebraska. He goes, you want to know what those two guys will have in common when he gets there? I said, no. He goes, they still won't be able to beat Ohio State.
McCaffrey.
I don't think McCaffrey was
like
in the
3
field.
days ago.
No?
He's
You what?
I saw McCaffrey like 3 days ago.
Yeah?
Panthers McCaffrey.
Panthers McCaffrey, very good.
Luke's just too little. I don't know what he's playing.
Yeah.
You should roofie him before a game, and then after the game, whenever he wakes up, just say that his team lost.
He's a
Just fix that.
Yeah.
I feel like Justin's my friend, and I haven't really slowed down my speech when I talk to him because he is an Ohio State fan. So.
Yeah.
All right, I am on that review sheet, letter M. So why don't we take a look at problems number 1 through 10. Take a good look and see if any of those need to be addressed.
6.
Number 6, you got it. All right, number 6, they want us to graph it. All right, that should be good enough. All right, number 6. We got Q at x, which is the same thing as f at x. Okay. So we would like to graph this, and this, our starting point has 2 shifts. The first shift is down 3. Agree? And the other shift is close, because it's 5 minus x, it does opposite of the 5. So it's -5. So -5 left and down 3. So it starts about right there. So -5, -3. Is that okay? So then you're like, okay, but I don't know what this graph is going to look like. Yeah.
Is it when it's in a square root, isn't it trying to cancel the other numbers? So shouldn't it still be a +5?
So if it's ever grouped, you'll shift it the opposite way of what you're doing. So if it was listed as x minus 5, it would shift right 5. But because the 5 is positive, it's going to still shift left 5.
Oh, number 5.
Okay? So what this negative x is going to do is that's going to make it go this way. Okay? So our starting point will be here. So that's basically what it's going to look like when we graph it. So with that knowledge, so that negative does that. If it was a positive x, it would have gone this way. So if this was x plus 5, it would have gone that way. But because I have the negative x, it's going to go this way. So let's plug in values to the left of -5 to see where the next point might be. So I might pick -6 and do that. Is that okay? Okay, now I get root 11, which I'm not quite sure what root 11 is. So let's figure out another value I could plug in that would make this a perfect square. That's negative to the left of 5. What can I plug in there that's going to give me a perfect square? It's got to be a negative. If I plug in -4, that's
9.
fine, but -4 is to the right of where we want to be,
9.
and that's not going to work.
-9.
-9, that'll give us 14.
Oh.
Let's see.
So,
So perfect squares would be like 1. Is there anything I can plug in there to get a 1?
No, do 11.
7,000.
16.
Do what?
11.
Do it 11?
16.
Okay, so I'm going to take a negative 11 and plug it in. So that gives me 4. Half of 4 is 2. 2 minus 3 is negative 1. So I get negative 11, negative 1. So negative 11 is like here. Negative 1's here. So this is basically what that graph is looking like.
Nice.
Okay. Number 6 does this. It asks for the domain and range. So once we have this graphed, our domain, it's coming from negative infinity and going all the way to negative 5 and including negative 5. And then my range starts at negative 3 and goes up. There's our domain and range. Yes?
I'm just confused because the answer key is a positive 5 and has a
It's on the other side.
of the axis.
The graph is going the same way, but is that positive
Yeah.
5?
Maybe they goofed up.
Okay. So maybe what they're thinking is this. Let's see if this works. Let's do this in green. We'll do an adjustment in green. If I go 5 minus x equals 0, I'm going to get negative x equals negative 5. So that gives me x equals 5. And that exists. So 5, 3, 3. So they have their answer like this, right?
Yeah.
Hang on, let's see if we make that right. Okay, I made an error. Okay, so the green is correct. The negative will indeed flip it the other way. So maybe if you look at it this way, and then your domain would go from negative infinity to positive 5, square bracket. Our range is still going to be the same. You're right. I made an error. So this right here, I put a straight through. I would go with the green. Yeah, take what's under the radical, set what's in the radical equal to 0, and that'll give you your shift. I'm sorry, I didn't mean to do that. Thinking too many things at once.
Oh, okay.
Cool.
So if there's a negative under the radical, it flips which direction the parabola is going.
If the x value is negative, you have a negative x, that's going to flip the direction that it would have originally gone.
Okay, but if it's outside, then it flips like upside out.
If it's
Right side up.
yes, you're right. Yeah. So if it's outside of it, if we had the negative in front of the 1/2, it would have made the graph go like this, go like this. And if you had them both inside and outside, it would still be the green, but it would be the flip over the green going this way. Okay. I made an error. I'm sorry. I should probably prepare for class better. What are other things on that first page would you like to take a look at? Four? Okay. 4 is another graphing one. Okay.
Is there gonna be a lot of graphing in the quiz?
Not as much as you think.
Is that the
Just some
non-calculated
stuff,
part of the test? Is the graphing the part of the test that's no calculated?
Yeah.
Okay, cool.
Alright. So number 4. H at x, which is the same thing as f at x. Okay. So we want to graph this. Is x to the 1/2 a square root?
Yeah.
So the domain of this
is 0 to
Right, 0 to infinity. And then the range of this, let's graph it first, take a look at it. So we're graphing this, is what we're graphing. And so it'll start at 0, 0. Okay, and we have that negative out front, so it's actually going down. So if I plug in perfect squares, like if I plug 1 in, square root of 1 is 1. Negative 2 times 1 is negative 2. Oops, I went too many over. Yeah, right there. So 1 is halfway in between, so it's right there. If I plug, say, 4 in, square root of 4 is 2. 2 times negative 2 is negative 4. So 4, negative 4. So this is what our graph's going to look like. Now we can figure out our range. So our range is going to continue to go down this way. So it's coming from negative infinity, and it's going all the way to 0.
Why does it only have one side of the parabola?
Because I have a square root, I can't plug negative numbers in. Cool?
Yeah.
What else would you like to see on that first page?
Can we do like one of the functions?
Where you?
Functions.
Where? Give me a number.
Like the bottom page.
Number 10.
10? Okay. Number 10, they would like us to do h at x over f at x. So let's figure out what h at x is. They told us that h at x from above is 9x plus 9. And f at x is 2x squared.
It's J, not F.
That's a J?
No.
J. That's a J. X minus 3. Okay. Is that right so far? Okay. Let's figure out our domains of both. So the domain of this one will be, I could go, if I plug negative 1 in, I get negative 9 plus 9, which is 0. So my domain will go from negative 1 to infinity. Did they want the range as well? No? Okay. And then this has a domain of negative to positive infinity. So I now know that my answer has to have a restriction of it so far. So we're going to focus on this restriction here. Is that okay? That's the restriction we're looking at, okay? So then, when I take this problem, I have this over j at x, which is this. What can x naught be equal to now?
3.
3, okay? So x can't be equal to 3 here because that would make my denominator downstairs. Now, is from 3 to infinity, does that include more or less numbers than negative 1 to infinity?
Less.
Has less numbers.
It's
Okay.
stricter.
It's stricter. So
Just
I
like my
can't go into any of the negative infinities, but I can go, because of that, I can go
3 to infinity.
negative 1 to 3, 3 to infinity. So that's my new restricted domain. And if you look at that long enough, you're going to see why does that negative 1 still fit in there? Well, if I take negative 1 and plug it in the bottom, I get negative 4, so that's no big deal, right?
Yeah.
But if I still plug negative 1 into the top, I still get 0 on top, so I can't go any smaller. I can't put like negative 2 on or something like that.
Yo no sé lo que me pasa.
Cool.
In English,
I don't know what's going on.
come see me.
I will.
Yeah, which one would you like? Number 9? Number 9, we got g at x and j at x. And we're multiplying them, right? So So they told us g at x from above is x squared minus 1. And j at x, they told us, was x minus 3. Are the domains of both of those negative to positive infinity?
Yeah.
Yep. So domain of this one is negative to positive infinity. Domain of this is also negative to positive infinity. So we might not have any restrictions on our answer. So let's take a look at it. So we're just going to multiply these together. So I'm going to go x squared minus 1 times x minus 3. And then if I multiply it out, I'm going to get x to the third, because that was that. And then minus 3x squared minus 1x plus 3. Does that have any restrictions?
No.
Excuse me.
Bless you.
Thank you. So being my original domains weren't restricted, and this doesn't appear that we're going to have any restrictions on it, we're free to go ahead and say that my domain of my found function is this.
Wow.
Yeah. No?
Do you have a meeting tomorrow morning? Or? Yeah.
I will be back in my office by 7:35, 7:40.
Okay, so, cool.
Cool. Got band practice. Got the band back together.
14.
14. Is everyone good with the front side?
Yeah.
We're good? We can come back to it if you need to. We also will have time tomorrow to go over any as well. So if you come across something later, going, holy cow.
No,
Thursday.
Oh, wicked.
I start trig. Start trig tomorrow, but. Okay, second page. You said number 14?
Yeah. Like radical.
Number 14, we have h at g at x, so we're plugging a function into a function. And they told us that h at x equation is
Radical 9x plus 9.
there you go. And then g at x is x squared minus 1. So am I restricted on top? Yeah, it goes from -1 to infinity.
How do you know if you're restricted?
The radical with an x underneath it, I can't have. If I plug like -2 in, this becomes negative. If I plug -1 in, I get 0. Square root of 0 is totally fine. Okay. Is this one restricted? No, it's just raised to a power. No domain or no radicals or no denominators. So one of them is restricted, one of them is not. So we have to have at least this restriction on the rest of the problem. So then I'm going to take highlighter. I'm going to take g at x, this,
And you plug it into x.
and it's going to plug into x right here. So that is this. Okay? So I'm going to replace x on h at x, the root 9x plus 9. Where that x is, I'm going to put x squared minus 1 in. Is that okay? All right, so I have hg at x. That's going to give me root 9. There was an x there originally. That was my x in my original. But now I'm going to plug x squared minus 1 in.
3x.
Do what?
3x is what you get at the end.
Oh, like I have everything up there, right? So that's going to give me 9x squared minus 9 plus 9. So my answer comes out to 3x. Was I restricted on anything above?
Yeah.
So I have to be restricted below.
-1 to infinity.
Even though I can still plug more negatives in here, I can't do an operation to my two originals and have a less restricted domain. So that's why we have to do that.
Nice.
What else? Any side?
I guess it's not that bad. Can we do 27?
Yeah. And then we have that third page here too, right? There's nothing on the back of it though. 27.
The weird shape one.
Oh, okay. So sketching. Oh, thank you for asking on this one. You will see one very similar to this on the test. And this seems to be pretty complex. Should be enough.
Which number?
This is number 27. Okay, so looks like I have negative 6, 1. Negative 6, 1. So I have this point right here. So I'm just going to write that. I have negative 6, 1. And then I have another point, looks like negative 3, 2. Negative 3, 2. So I also have negative 3, comma 2. So those are connected like that. And then it jumps up to negative 1, 6. Negative 1, 6. So I'm also going to list that point. And this comes up here. Then it goes over to 3, 7. And this goes here. And then my very last point is 7, 6. Okay. So if you're just given that and it says, hey, graph the inverse function, what flips over in the inverse function?
The X and Y.
Yeah, so I'm going to plot the point 1 comma negative 6, 2 comma negative 3, 6 comma negative 1, 7 comma 3, and 6 comma 7. And we'll connect those in order. So 1, negative 6, 2, negative 3, connect those. 6, negative 1, connect those. 7, 3.
Yeah, this one goes off the paper.
And then 7, 3, we did. And then 6,
7.
7. I didn't mess up on the points, did I? Let me just verify 27. So I have negative 6, 1, agree. I have negative 3, 2, I agree. I have negative 1, 6, I agree. I have 3, 7, I agree. And then I have 7, 6, I agree. 6, 7, 6. So that's what that one looks like. It's already time to go? All right, so office tomorrow from about 7 a.m. on. And I'm still off periods 1, 2, 4, and 7. And then I'll be in my office today after school today. After school today. I'll be in my office as well, okay? Well, today I gotta run a 6 o'clock game, so I'll be in my office until about 4:30. Cool? Deal? Everyone happy? Thank you. Yep.
Does this review everything?